Good evening, fifth graders. Hope you had a great day. And I wanted to just talk about lesson 4.1. I know that some of you have been a little confused with 4.1 and 4.2. Part of that is that I wanted you to kind of explore these problems, and I know that adds some confusion, but I wanted to just give you the answers to 4.1 so you can see, oh yeah, that's the way it's done. Anyway, if we were to complete the table here for the ladder, every time we have a new square that's added, we add 3 steel pieces. So 2 would have 7, 3 would have 10, 4 would have 13, 5 would have 16. But then what happens when you get to 10 or you get to 20? Now, if you look from the 1 to the 4, and we know that very first square has 4. After that, every time, we're just adding 3 more each time, right? Because this 1 right there is shared. So basically, there are a couple ways that we can look at that. Remember, the dependent variable always goes first, Let's say P for the pieces equals, well, we could say 3 times the n. All right, so here, let's say these 3, these 3, these 3. But remember, we have this 1 right here. So we have to add that plus the 1. That's always the one that's shared. So 3 for every new square plus the 1. Or we could say the amount of pieces is the original 4 plus 3 for every new square. Now, the first square is not really new. So we could take that one out by saying, okay, well, it's 3 times the amount of squares minus 1. So the first square is the first square, 1 minus 1 is 0. So it's really p equals 4 for the first square, which is what it is. Remember, you can always make sure that you have the right equation by putting in a number. So if we were to put in, say, the number 5 right here, we could say 5 minus 1 is 4, 4 times 3 is 12, and 12 plus 4 is 16. And therefore, that is our answer. All right, now with cubes, it's a little bit more complicated. And the first cube, as I showed you in my example, had 12, right? And every time you stack another cube on top, it's a little tricky to draw this, like that. Well, are we adding another 12 or are we adding less? Well, we're actually adding less. We're only adding 1, 2, 3, there's one in the back here, 4, 5, 6, 7, 8. We're really only adding 8. So, a couple ways of thinking about this one. We could say that the pieces of steel equals 8 times the amount of cubes plus 4. Because we've got these 1, 2, 3, 4 that are shared. In the first example, we only had 1 that was shared because it was one-dimensional, or two-dimensional, sorry. Now we're 3 dimensions, and so we have all 4 of those squares. So every time we add a cube, we're always sharing at least those 4. So that's why if we said 3 cubes, it would be 8 times 3 is 24 plus 4 is 28. So this would be 28. All right, 2 cubes would be 16 plus 4, which would be 20. Now, you could also think about it as what we did in the first one, letter A. We could say, okay, well, the first one has 12. The first cube has 12. Plus, we're going to add 8 for every other cube, which in the first case, for the first cube, we're not adding a cube, really. It's the first cube. So if we were to solve for the first cube, we'd say 8 and 1 minus 1, 12 plus 8 times 1 minus 1. Well, this is all 0, so that's 0. 12 plus 0 is 0. say we wanted to do 10 cubes. Well, 12 plus 8 times 10 minus 1, which is 9. 72 plus 12 is, it's hard, at the bottom of my screen is 84. Or we could try here. 8 times 10 plus 4 is 84. All right, so this is 84. 20 would be 164. All right, so these are the equations. Remember, as I said before, you will know if these equations work by trying them out. And so in problem 4.2, that's the way we realized that Luttrell's equation was different than Chaska, Eva, and Tabitha's, because we tried them out, and when we solved them, Luttrell's answers were higher than Tabitha, Chaska, or Eva. Okay, that's how we know that Luttrell's equation was not the same. All right, I hope that all helps. I hope you enjoyed my Thursday evening video, and I hope you enjoy Flex Friday. Remember, anything that you do tomorrow, besides any missing work, is optional learning on your part. Have an awesome day and have an awesome weekend.